Cordial greetings. My name is Stevenson Estrada. I am a student of electronic engineer. This is the course sensor for iode, and this is the phase 2. And this presentation, this video is about static and dynamic characteristic of sensor. In this case, specific response time and hysteresis characteristic. Okay, the sensor has several characteristics that can be static or dynamic, depend of the response over time. For example, when the characteristic change over time, this is a dynamic characteristic. Is the characteristic of being able to respond for a stimulus over time. But a static characteristic is when the property don't change with or over time. For example, accuracy and precision are static characteristics, sensitivity and resolution and static characteristics. But the response times, the hysteresis, the dynamic error are dynamic characteristics. In the work of these phases, I present two images, two pictures. In this picture, we have on the left the response times, on the right the hysteresis. In the response times is the time after the constant time. This is the time when the sensor starts of the reading and rises almost 70 or 75% of the magnitude of the output signal, input signal. Okay, the input signal. Receive this input signal and start to measure, and the time that the sensor take to measure the 90% of the real value is the response times. And this is a tolerance bands depend of the sensor, depends for each sensor or variable to measure. Different variables have different response time. For example, the temperature have a long response time, and the speed or angular speed have a more faster response time. Uh, in the other hand, the hysteresis is the error to measure the output ideal curve. Okay, the ideal curve have this threshold, and the real measure have this shape. The difference with linearity is that the hysteresis have some values above and some values below the ideal curve. So the hysteresis is a property that changes when the signal load or unload for the sensor. Response times is defined as the period in which the sense variable presents a considerable change of state. This is that I explained the tolerance band, no? And the hysteresis in the other hands uh, is basically the ability of the sensor to follow the ideal output curve. That is the idea, no? This is the real response. This is the real response, and this is the ideal response curve. The ability to follow the ideal response and which values above or below is the hysteresis. And the hysteresis depend of mechanical, electrical, or uh, physical properties of the sensor and its components. It can affect the accuracy or the precision of the sensor and in the other characteristic. It's important to understand that because I select if I want to select some sensor for different request or a specific project we need to evaluate these characteristics, static and dynamic, and if I need more precision, lowest hysteresis, lowest response time. I need better materials, better components in the sensor, and maybe this sensor is expensive for the project. But some project is enough with a acceptable response, not longer, not so short, and this sensor have a cheaper price than others, but enough precision, enough accuracy, enough time response, enough hysteresis for the application in specific. Well, I would like to show you in the last minutes the presentation that I made for the other classification of sensor, for the classification according to transduction principles, for transduction principles. This presentation is interactive, is dynamic, and was made in genially.com. You will see that have the different kind of sensor according to the transduce principle: piezoelectric, capacitive sensor, piezoresistive sensor, ultrasonic sensor, thermics sensors, chemicals, and photoelectric and magnet transduction, and different interactive points. For example, this is the concept, yeah, and this is a image with this explain that the chrome preset in the sensor generate a change in the resistance and change the voltage output. This is the reference. This is bibliography. And another resource, like for example, okay, for example, that this have give to motion with motion and observe it change of the resistance by electrical and chemical, sorry, and chemical value. And another have, for example, a video, for piezo resistive have image, ultrasonic has another image, photoelectric has a video record. For example, this is the concept and this is the video, and the video show another characteristic, another concepts explain about the functionality of the sensor. This is photoelectric sensor. This sensor used like sensitive element to detect objects are made up of an emitter and receiver. This is emitter generate a beam like, and a receiver measure that a reflection or refuses the signal. For example, in this case, the reflection don't receive the signal and count one or two systems for that. And it's all. Thank you for all. See you later.